Hello, my name is שוואנק. I am an assistant professor at the University of Florida, and today it is my pleasure to talk to you about Formosan succulent termites and their problem as pests in parts of the world and now in Israel. To start, let's talk about what are termites. They are technically social cockroaches, and there's about 3,000 species described around the world. But only a fraction of these are actually pests, which means they're a problem to us humans. They all feed on some kind of lignocellulose, which means wood, paper, or organic material. But they are unable to digest the wood on their own. They require the use of symbionts in their gut to do the digestion. And they are all eusocial, which means that they do have a cooperative brood care, they have overlapping generations, and they do have reproductive division of labor. In other words, they have castes that do different tasks within the colony. And these castes are morphologically easy to determine. You're going to have the king and the queens that are in charge of reproduction, and the rest of the individual will be sterile and are in charge of taking care of the tasks within the colony. They lay the eggs that will grow into larvae and workers, and some individual will be in charge of defense with morphology adapted to defense, and we call them the soldiers. A colony, life cycle of a colony is a bit complex, but when you have a mature colony producing the winged individual that we call elate, they fly away, find mates, and eventually hide somewhere in the ground or in trees. Then they mate, which allow them to lay eggs, and these eggs will hatch into larvae, which grow into workers that are bigger and bigger over time. Also, some individual will eventually grow into soldiers. And finally, when the colony is big enough, it can produce the nymphs, which will finally turn into winged individual, which will complete the life cycle. And this takes about at least 5 years for a colony to complete its life cycle. So when a colony is swarming, we know that the colony has been established in the area for at least 5 years, maybe more. Eventually, some colonies have the ability to produce a secondary reproductives, which allow them to have an individual that lay more eggs, basically, for the colony. And these colonies are allowed to grow with multiple millions termites, which is why they can be so damaging. It's just there's so many mouths to feed. So this is when the colonies are producing these winged individuals that are flying out so they can hope to make a new colony as kings and queens. For me, this is the time of the year where I can make colonies for my research in my lab in Florida, which happens sometimes in May. For you in Israel, I was told it's around June or so. There's a slight delay. But this is a light trap that I put together, that I put in front of my own house. When the swarms happen, I can collect them and bring them back to the lab so I can study them. Eventually, I can pair them with my male and female, which allow them to mate, produce offspring, and as the years goes, I transfer them into bigger and bigger container so I can grow them and study them at the colony level. So a lot of my recent research was done using this process to study termites at the colony level, not just at the insect level. It requires a lot of work and know-how, so we can grow them to multiple millions termites per colony, as you can see here, which means we do produce a lot of destructed wood in the process of feeding these colonies with actual wood that we use to build our houses. So I use Koptotermes as a primary biological model, where I can study any aspect of the termite biology, which eventually allow me to understand their biology in a way that we can exploit their weaknesses to protect structures, to prevent damage. Now, the Formosan succulent termite, also here known as Koptotermes formosanus, is invasive in the United States and is found throughout the southeast US in this subtropical environment. And here I am in South Florida, where not only we have the Formosan succulent termite, but we also have a similar species called Koptotermes gastroi, also known as the Asian succulent termite, where we have two of the most damaged termites in the world. The reason is, Koptotermes, we know there's about 21 species distributed throughout the world, but out of these 21 species, only 2 are known to be fully invasive and have done a lot of damage, so are known as pests in many parts of the world. So if you look here for formosins, they are native from the Chinese, Taiwanese area and have spread in many islands and in the Southeast US. And more recently, we discovered now in parts of Israel. But in red here, we also have Asian serpent termite, Koptotermes gastroi, which is basically throughout the tropics now and is one of the most successful invasive and destructive termites in the world. In Israel, in the past few years, several locations have recorded activity of the formosan serpent termites. And although it's only recently that it's been confirmed as formosan, the fact that they have been spread out in many cities throughout parts of the country means that they've been here probably for 1 or maybe 2 decades. It's really difficult to tell. But it's important is we know that the climate in the area is not really the best for that species, where it requires a lot of moisture. So it's possible that urban irrigation has facilitated the survival of that species and allowed it to thrive potentially and establish and now causing damage in these locations where it is established. This is only the tip of the iceberg. These are the ones that we know have been reported, but it is very possible that the species is actually much more spread out. It's just that nobody found a sample and confirmed that it is established. So it's only a matter of time before more locations are found. And the pest control industry is fundamentally important because they are the eyes on the ground to be the first one to detect it and recognize it. So it is important that the pest control industry is aware of this issue, because it's not going to go away and it's going to become a norm in some of these communities in these cities. So invasive serpent termites, as Koptotermes, can do extremely large colonies, as I explained earlier, and they can do this massive swarm, which usually is the time of the year when people realize they have a termite problem, because you have these winged termites flying everywhere in the neighborhood and sometimes in people's house. The problem with this formosan serpent termites is they can do colonies that are foraging in the ground for extensive distances, up to 100 meters. So this means that when you find an active infestation, you don't know where the rest of the colony is. It can be anywhere within a 100-meter radius. You don't know where the king and queens are. You don't know where the rest of the brood is. You simply see a point in space where they are foraging. It can be a tree, it can be a structure, for example, but we don't know where the rest of the nest is. What we know is as they forage underground and they hit some root system or some electrical conduits or some plumbing pipes, they're eventually going to follow them, which lead them straight to a structure. And you can see here the mud, which is typical activity from formosan serpent termites, covering the pipe and bringing a highway of termites straight to the structure. And you can see here in the crawl space of that structure how it's found its way to the floor, which it completely chewed up. Once in the structure, they can expand through the walls and have access to other food particles within the structure. Here, for example, around the windows or directly within the walls. And this can be a problem because by the time the customer realizes they have a termite problem, when you deal with a formosan serpent termite, it's often too late, where the damage is already quite extensive. So it's a very unfortunate pest to have, because by the time you realize, it might be too late. But keep in mind that the colonies, the colony as a unit is not really just located into that structure. The rest of the colony and the brood system can be hundreds of meters away, so you have no way to know. One important thing to know is that formosan serpent termites tend to start their colonies at the base of trees, where they have a food source and potentially a source of moisture that they require. They cannot survive without water. And as they infest these trees, they will do a lot of damage to these trees, and you're going to have a lot of signs that tells you have an active infestation in these trees. Often you can detect the termite activity in the tree before they are even in structures. So tree inspection is actually very important when dealing with Formosan succulent termites. This is also very important because over time they will do a lot of damage. We say that they pipe the tree from the inside, and eventually the structural integrity of that tree is going to be not sustainable. And here in Florida, we do have hurricanes and storms that will take these tree downs that cannot survive such strong winds, especially if the trees have been completely compromised by the termites. So you want to find some invasive Formosan succulent termites? I have a simple advice. Check for trees. Chances, if you're in an area with known infestation, this is the first place where you're going to find them, especially if you know exactly what to look for in terms of sign of activity, with mud tubes or carton material coming out of pruning wounds. Now, important, these colonies don't just appear from nowhere. They take time to establish. So before you reach millions of individuals, the colony will grow over time. And it's go from birth to colony growth to millions of individuals. And finally, when the colony has a critical mass of individuals, they can produce elates, the winged termites. And this is the reproduction part of a colony. It's going to do this for many years, and eventually the colony will go through senescence and death. So the colony go through its own life cycle. We're not talking about the individual, which means that within the first 5 years, the colony is just going to focus on growing itself by producing more workers and more soldiers. But when finally it reaches maturity, seasonally, it's going to produce these swarms to find a mate and make new colony. If a colony has the opportunity to produce elates and swarm and make more colonies, it wins. It has the ability to multiply itself and create more colonies that can establish and create damage. Through this time, the queen is going to grow. Here is a Koptotermis gastroi, but similar with Formosan, where you can see the queen start with as a simple D-elate individual and will grow eventually as this fundamental egg-laying machine, where the abdomen goes through physogastry and means that she can lay a lot every single day, allowing the colony to reach these very large populations. So within a mature colony, each individual has a chance to become either a soldier, either a worker, or either a future reproductive, either as an elate or a secondary reproductive. And as you can see, each stage, the termite has to molt to be able to go to the next level, basically. And this molting behavior drives a lot of the biology of termites here. And what's important is every time a termite is ready to molt, let's say this worker that has been at the foraging site feeding on wood, ready to molt has to come back to the center of a nest to be able to molt safely, shed its old cuticle, create a new one, and go back to the foraging site to chew on more wood to feed the rest of the colony. So this is what we call the molting site fidelity, where they have to go back home to molt safely. Now, we have these termites that can grow these large colonies and can do a lot of damage on structures and trees. What are currently the methods of control that are accepted, let's say, around the world to deal with Koptotermis as a pest? The primary way and the primary historically way to do it is the use of liquid termiticides. The more recent one, which came up in the mid-90s, is the emergence of chitin synthesis inhibitor baits, or CSI baits. And these two methods of control are fundamentally different and impact termite population very differently. So let me go through it briefly. With liquid termiticide, the goal here is to create a chemical barrier around the structure. Nobody shall pass to access the structure. Now, most of these products are non-repellent, which means the termites don't really detect them and they can go through the soil not knowing it's there. But it has a broad spectrum insecticide, which means that anything that has 6 legs that is in contact with this will die. It's a fairly toxic compound if you think about it. They have to be non-water soluble because we don't want it to be washed out down with rains, for example. And it has to be non-persistent. We want it to degrade over time so we don't have bioaccumulation in the environment, like it happened with previous termiticides that are still in the environment because they don't degrade very well. All of these liquid termiticides are lethal time dose dependent, and that is a very important point. It means that the more you put, the faster the termite dies. Dose tells how fast the termite will die if exposed. With chitin synthesis inhibitor baits, or CSI baits, the goal here is different. We're talking about colony elimination. These baits have to be non-repellent. We want to make sure that the termite is able to feed on it. The colony needs to be able to access and feed it. So if it's repellent, they're not going to go anywhere close and therefore not feed on it. These formulations are termite specific. So nothing else are going to be affected because only the termites have the ability to access it and feed on it. The thing is, these compounds don't really kill the termites right away because it only activates when the termite is ready to molt to go to its next instar, like I showed you earlier. This means that CSI baits are lethal time dose independent. That means they can chew on the bait as long as they want. It's not going to really affect them, which gives time for them to share the food with everybody in the colony. And eventually, as each termite independently must go through their periodic molting process, they are eliminated in the process. They are killed in the process, which over time, all the termites have to molt, all the workers have to molt, and everybody dies within 90 days or so. So here you eliminate the colony through the feeding with a very specific type of baits, CSI baits. Now, let's look carefully at how really these two methods impact subterranean termite colonies. This, I was able to use the colonies that grew in the lab over many years. And this is give you an idea of the scale of experiment that we were able to do in the lab so we can see what's happening when we use either one of the type of treatments, either baits or either liquid termiticide. This gives you an idea of the scale, which is we need to use this for distance. Distance is everything in how control method works. The way we did this is we create a system of tubes and tunnels where we can see in these arenas the termite activity over time. We have on one side the center of a colony where we have about 60,000 termites. And at the very end, we have what we say the house at 12 meter, which is basically an arena filled of wood where they can consume over time. And then at 3 meter, we split. So they have two ways to access the house. But we're only going to treat one side of a treatment to simulate that only one bait station was hit and eventually missed the other bait station. Or to simulate that the chemical barrier was incomplete and the termites found a way to bypass the treatment either on the side or underneath, for example. Therefore, still have access to the colony, although one part of the colony is exposed to either the bait or the liquid termiticide. Over time, we can count the termites in the arenas, and at the house, I can estimate how much wood has been consumed over time. So let's take this system, spin it sideways so we have a better view, and focus only of the amount of termites active in these arenas over time. Let's start with the control, which means I only put a piece of wood, no products. And we can see that the termites are in the arenas from 0 to 84 days, which is the 12 weeks mark. And you can see that over time, they're going back and forth to the house, and activity remains fairly stable over time. Now, let's use now the case of liquid termiticide. In this case, I use fipronil. And what happened is you can see that the activity at between 6 and 9 meter on the side I put the treatment just stop radically within a week or so. And what we have is an accumulation of dead termites in these arenas. But what happened really quick is they closed the access to this arena and sealed it because of secondary repellency, which means that although we know that these liquid termiticides are non-repellent, because they kill the termites too fast, which trigger them to die very close to the treatment, you create a dead zone where the rest of the colony is going to say, we're not going there because we're all going to die. It smells like death. Block the tunnels and therefore go somewhere else. And if they have somewhere else to access the structure, they will continue to infest the structure regardless of the treatment at this point. For baits, it's a complete different story. Nothing happened within 45 days. The colony remained fairly active within 45 days. But between 45 to 84 days, the 12-way marks, the activity just vanished. It's not like I'm finding any dead termites in the system. I don't find any more termites. Everybody is gone. So what we did is we went back inside the colony to look at what happened to these termites. And what we found out is termite colonies that were treated with the control and the fipronil had no significant difference. So we just killed a few termites in the system that were close to the treatment with liquid termiticide. However, the colonies treated with noviflumaran, virtually everybody was dead by 12 weeks. Number of soldiers didn't change much for noviflumaran treated colony because soldiers is a final cast. They don't molt. Therefore, they're still waiting at this point for workers to feed them. And what happened is, at this point, they are in the process of starving to death because they don't have the ability to feed themselves. This results in aberrant soldier ratio toward the end of a treatment. As you check the bait station, all you're going to find is soldiers that are in the process of starving to death. So at 90 days, all colonies that were treated with the bait were eliminated, while all the colonies treated with the liquid termiticide ignore the area that was treated and continue to feed on the other side like nothing happened. So the reason here we couldn't find any activity of termites in the arenas that were treated with bait is because they didn't die at the site of treatment. They died back at the center of the nest. As they go back here, try to molt, and die there. This means that you're going to have death zone accumulating right where the king and queens are. And this is important because it's going to force the king and queen to move somewhere else, and eventually to one of the few places where there's no death, which happens to be the bait station, ironically. At this point, the king, the queen, the soldiers are all in the process of starving to death. If we look at the consumption at the house, at the beginning, consumption was identical. Halfway with the system, we have a reduced consumption for both treatments. But as the termite in the fipronil, the liquid termiticide treatment, were able to find their way back through the area that was not treated, they resumed consumption, while for the noviflumaran, the bait-treated colonies, consumption stopped, and eventually the damage also completely stopped because all colonies were eliminated by 90 days. If we look at the queen, at 84 days, she's still alive, but she lost most of her weight because she's starving to death. What we also found is the brood is gone very quick. So the eggs and the larvae are basically eliminated really quick until eventually the workers start dying and from the molting, failed molting, and then the soldier and king and queen starving to death. So with liquid termiticide, essentially what you do by doing a chemical barrier around the structure is putting a Band-Aid. You're preventing it from accesses, but ultimately, and it's true with Formosan succulent termites a lot, they'll find their way back inside the structure over time. In comparison, when you use baits, all it takes is feeding on a single station to accumulate sufficient active ingredients to share with the rest of the colony to eventually reach colony elimination. So to summarize, with liquid termiticides, chances the termite colony survives the process and just going to go somewhere else, at least for some time. It only kills the termites within 3 meters of a treatment. Beyond that, it seems the colony doesn't really care. And if termites found a way around the treatment, the infestation and the damage therefore can continue, which usually is not great news for the homeowner. With baits, as long as you have feeding, so that means the colony has the ability to reach the bait station and feed on it, the colony stops feeding around 45 days. Even though you still have live termites, they're done feeding at this point. Termite colonies are eliminated within 90 days, and the elimination occurs regardless of the distance of the bait. It doesn't matter where the colony is. All you need is feeding on that one station, and it will spread throughout the system over time and therefore reach colony elimination. One of the questions I have a lot is how much bait does it really take to eliminate the colony? So I took the bait station, cut it into cubes, and give it to the colonies for feeding. And I give it for 1 day, 3 days, and 10 days. And this is eventually what they ate within this time period. What we concluded is the colony feeding on a single day was enough to reach sufficient ingredients to spread through the colony to reach colony elimination. And we estimated that we need only 18.6 grams of bait formulation to kill 1 million termites, which means in terms of active ingredients, it's 93 milligrams of active ingredients to kill 1 million termites, which is virtually nothing. It's a tiny, tiny amount, and it's all it takes. And only the termites have access to it. So it's by far the most environmentally friendly system that are there to eliminate termites and to protect structures and trees. So you only need 1/3 of that bait to kill 1 million termites. That's what it says. More recently, 2 of my students helped me with that study, and we show that it takes less than 5% of the workers in the colony to have access to a bait station to feed on it, to sufficiently acquire the bait formulation and share it to the rest of the colony. Less than 5% and feeding on a short duration. This study, we used 1.7 million termites to prove that, which was quite interesting. So to summarize, let's look at the baiting process step by step. First, the foragers are going to feed on the bait station that you provided them. As they find it, or you put the station where they are. And we show that a single day or few days at least, and less than 5% of workers feeding on that station is sufficient to acquire colony-wide elimination over time. But before this, these foragers are going to share the food with the rest of the colony, which results in the primary spread of a bait throughout the colony. When the first few individuals are ready to molt, go back at the center of a nest and die there, what happens is they are going to be cannibalized because termites recycle their dead very efficiently. This leads to a secondary spread of the bait, and therefore the king, the queen, and the larvae are going to be further exposed to that bait. The queen, at this point, stops laying viable eggs because although she doesn't molt, the eggs need to create a cuticle, and therefore the eggs failed to hatch when the queen is exposed to the bait. Also, the larvae that need to molt rapidly also die in the process. So really quick, the brood within 20 days is gone. Then the workers stop eating because they don't feel great, and they eventually die progressively between 45 to 90 days. At this point, the soldier, the queen, and the king die of starvation, leading to colony elimination. That is a process of a classic bait protocol when you're dealing with Formosan subterranean termites. Now, this is a summary of the comparison of a two-control approach. With baits, the goal is colony elimination, while liquid termiticide, the goal is to prevent access of a colony to the structure. Quickly, with baits, we eliminate all colonies feeding on bait station. So you can kill one colony with it. And eventually, if another colony comes, find the station and feed on it, it will also eliminate that colony. Bait is using a slow-active ingredient, which is lethal time dose independent. They're non-repellent and only kill termites when molting at the center of a colony. They spread through the colony before mortality occurs, which is very important because it allows the product to be shared with no impact on the colony. But by then, everybody has it. Therefore, as the brood is the first one to molt, is affected first, and you eventually kill the workers too. The formulation is termite specific. Nobody else is going to be affected by this, and it eliminates the colony regardless of the distance from the baiting. With liquid termiticide, here you create a protective chemical barrier around the treated area. But it's fast acting, therefore it is lethal time dose dependent. And because it kills the termite too fast, you create a dead zone that creates this secondary repellency that kills termites near the treatment. The spread of a product is only going to spread up to 3 meters. That's it, no more. So distance here is very important because it only primarily kills the termites that were directly exposed to the foragers. The transfer is very limited. It is a broad-spectrum insecticide, which means it can kill any insect, not just termites here. And the colonies can survive, which means that eventually, if it stays around, and eventually if the chemical barrier degrades over time, it will find its way back. Or in the case of Formosan certain termites, they will find a way around it because they're fairly aggressive species. One thing to remember is if a termites complete their life cycle by producing these swarms, these winged termites to make more colonies, they win, essentially. So if you don't eliminate the colony, but you just temporarily protect the structure with liquid termiticide, you don't really do much because you allow more colonies to establish and the potential for damage keep increasing. By this biological reality, the large use scale of liquid termiticide is simply not sustainable because it doesn't fit the definition of IPM, which is integrated pest management, which is a big thing in urban entomology. Here, we suggest that the only way to do termite IPM is to use CSI baits. Fortunately, now in the world, there's different formulation, different active ingredients that are available depending on the country. And I really hope that the pest control industry in Israel has access to different products with different ingredients and different formulation, so you can find out what is the best approach and what kind of product is the most efficient in making sure that termites can access the bait, feed on it, and be eliminated over time. These are the products currently available in the US, but outside of the US, a lot of different products are available. Finally, which is a very important thing for me, is inspections of structures and trees can be integral part of dealing with termite problems when you're dealing with Formosan succulent termites. Here you can see a mud tube going up a tree, which is classic what you would find with Formosan side. If you find them, you can actually implement a bait station exactly where they are. And in this case, it's for use an above ground formulation. Instead of planting it in the ground, it's a slightly different formulation that you put water in to make it moist and put it exactly where the termites are. The key here is they come for the moisture. Termites come for the drink, they stay for the food. If it's not wet, chances they will never get in and not feeding on it. And if you don't have feeding, you lose. If you have feeding, you win. It's a straightforward process. Here's a case where we just use staple to put that bait station directly on the tree where the activity was. A few days later, we came back and they were able to chew on it. At this point, I know for sure that within 90 days, the colony will be eliminated. So it's very important to set the expectation of what's going to happen when you start implementing either products. And the role of a pest control industry when dealing with termites is to minimize the potential for damage. With the implementation of regular inspection of trees and structures within the areas where we know formosins are established, is going to be a key component of the strategy to minimize the potential for damage. Because early detection is paramount. Seeing a mud tubes on a wall or mud tubes on a tree is a great opportunity to place an above ground bait station, for example, and kill the colony even before it's done any damage to the house or the tree. And by doing so, we can eliminate as many colonies as possible in this infested area. And I believe that area-wide management using bait technology can achieve a goal. And the goal is minimizing the potential for damage. Because there is one very important thing to understand, that once this termite species is established in an area, eradication is impossible. Because as soon as you have a swarm, you have hundreds of small colonies starting everywhere in the neighborhood. And therefore, there's no way you can detect them until they're mature and big enough to be found. So in these areas where formosins and termites are established, this is now the new normal. And this is what you're going to have to deal with pretty much forever. It's there. It's not going to go anywhere. But with an approach of minimizing potential for damage by killing as many colonies as possible before we get a chance to swarm and make more colonies, you can reach a sustainable program by keeping the customer with a minimal amount of damage and allow your business to thrive by providing a service to prevent damage in the first place. This is the expectation. Zero termites is unrealistic. They're here to stay. All you can do is make sure that the homeowner doesn't get their house destroyed by termites by doing proper inspection regularly in these areas. And also for the companies that are outside of this range to keep an eye for it, because you are the eyes on the ground who can detect it firsthand and report it. And when the community is now affected by the species, the whole community can prepare to prevent and minimize the potential for damage. With this, I would like to thank you for your time, thank all of my colleagues, coworkers, students, and collaborators that have helped me with my work in the past decade or so. I would also like to thank very much my contacts in Israel that have helped me understand the problem that you have there. Tomalu, who found and sent me the sample to confirm that Formosin was established in Israel, and Gal Zagran and Alan Baer, who really did a lot of work to help contribute and make this event happen today, to raise awareness, because once you know, it's half the problem solved. So I hope to continue this collaboration in the many years to come, and hope that the industry in Israel will be able to face this terrible pest that we deal here every day. And I know it's a formidable foe, but there's a way to do it, minimizing the damage, so to make everybody happy. And I hope you can achieve that. So thank you for your time. And if we have time, we will have some questions if possible. Thank you.